is Paul Diane, and I am a Senior Sales Engineer with InterSystems UK. Welcome to the Tech Talk on HealthShare Patient Index, Part 1. I've been with InterSystems for 12 years, and I work on the healthcare side of the business, specializing in our HealthShare products, our Health Connect integration engine, the FHIR standard, and general software development on our Iris platform. I also have a special interest in integrating with NHS spine services in HealthShare and Health Connect. Today we will start by exploring what Patient Index is and what it does. Spoiler alert, it does identity matching. But what does that mean and how does it work? Then we will look in detail at how we configure the identity matching using what is known as the linkage definition. Patient Index has a new feature called referential matching, which includes third-party identity providers in the matching process. And lastly, we'll also look briefly at the programmatic API exposed by Patient Index for use by custom applications. I hope you will also be able to come to Part 2 of this Patient Index Tech Talk. In Part 2, we will be covering configuring and using the work list, the Patient Index composite record, and Patient Index data quality reporting. So, what is Patient Index? Patient Index is an InterSystems software product that is a member of the HealthShare family. But what does it do? Let's start by exploring the problem that Patient Index is designed to solve. It starts with a scenario in which two or more systems, each with its own list of people, need to interact. That could be multiple systems in a hospital, or it could be a scenario that has nothing to do with healthcare. We will focus on a regional shared care record, where a central solution such as HealthShare Unified Care Record is receiving patient information from multiple sources such as hospital PASs and clinical systems, mental health, primary care, community care, social care, and third sector. Each has its own register of patients with its own patient number system, often referred to as medical record number or MRN. The job of the shared care record solution is to show the user all the information about one selected patient. In our example here, the user searches for Jane Doe, but each source system might have several Jane Does in its list of patients. How does the shared care record know which MRN in each source system is for the Jane Doe the user is looking for so it can show the right data? That's where Patient Index comes in. As the shared care record receives data about a patient from the source systems, it passes the patient's demographics, name, date of birth, gender, address, and so on, including the MRN, to Patient Index, which creates a central repository of citizen identities. When Patient Index receives a new identity from a source system, it compares the demographics with all of the identities it already has to determine which ones are for the same citizen and links them together with a common identifier that Patient Index creates to form a set for that citizen. Then, when the user searches for Jane Doe, Patient Index compares the user's search criteria with the known identities and presents the user with a list of one or more matching identity sets. The user selects the set for his Jane Doe, and Patient Index uses the MRNs in the identities to pull together the data for the selected patient. But what is so hard about this that we need a special product dedicated to identity matching? Well, first of all, there is no agreed set of demographics that each system should collect about a citizen, so the number of match points may be limited. And people make mistakes. For example, when registering a patient, the administrator may enter the day of the month and the month number in the wrong order, or misspell the patient's name, or enter the city in the street box. And demographics change over time: surname, address, phone numbers, gender. So the demographics held by the acute hospital that the patient attended a year ago may not be the same as the demographics held by community mental health that saw the patient last week. And there are common confusions, such as a father and son, both called John and living at the same address. Lastly, people often enter common placeholder values where their system says a value is required but is not known, such as the first name of a newborn baby. Baby is probably the most common first name in hospital systems, but we don't want that to cause their records to be confused. So why can't we just use the NHS number? The NHS number is intended to be the single unique identifier for patients in healthcare in England. So why can't we just use that to identify the patient in each of the source systems? Well, firstly, not all health and care systems are automatically synchronized with the Spine Personal Demographics Service, so they may not have a verified NHS number for the citizen. Social care systems may be a typical example. Also, the patient's NHS number may not be available in an emergency. And some patients don't have an NHS number, such as a new baby or a visitor from abroad or just from Scotland. So to recap, in what scenarios would we use patient index? It's basically any scenario where two systems are interacting and they each have their own list of patients without a common identifier between them, such as a regional shared care record or a hospital with multiple systems that are not all synchronized to the PAS, or a hospital group where the hospitals are using different PAS systems. Next question, how does patient index work? Well, patient index keeps a list of the patient identities it has received from the source systems. When it receives a new message, such as the demographics in an HL7v2 message from a hospital system, it first compares the medical record number, assigning authority, and facility in the message with all the known identities. But what do we mean by assigning authority and facility? The MRN is a unique identifier within one source system, such as 1, 2, 3, 4, 5, but there may be another source system with its own list of patients with a different patient with MRN 1, 2, 3, 4, 5. So we must qualify the MRN by the system that is using the MRN, such as a track care PAS. That is the assigning authority specified in the HL7v2 message. But there could be multiple hospitals using track care in the region, each with its own list of patients, in which the MRN 1, 2, 3, 4, 5 could be used for different patients. So we must further qualify the assigning authority by a code for the facility or source organization hosting the assigning authority. So if the facility, assigning authority, and MRN in the new message match a known identity, then the new message is treated as an update to the existing identity. For example, perhaps the patient's address has changed. Otherwise, it's a new identity and patient index adds it to the list of known identities. Either way, patient index must compare the new or updated identity to all the other known identities. Even if it's an update to an existing identity, the change may cause the identity to match an identity it didn't match before, or vice versa. But first, patient index normalizes the demographics in the identity. By this we mean eliminating differences that shouldn't affect the matching, such as removing spaces from the NHS number, and eliminating values that are not valid for matching, such as a first name of baby or an invalid NHS number. Patient index must compare the identity with all other known identities, which could easily be millions, making it a very costly operation. So patient index first applies some basic rules known as link key indices to weed out the obvious non-matches. For example, a link key index might specify that at least 2 out of first name, last name, and date of birth must match. And another link key index might say that NHS numbers must match. Unless at least one link key index shows a match, the pair are treated as an obvious non-match. If the identity pair get over that hurdle, patient index optionally checks for matching deterministic identifiers. These are identifiers that you have specified as trusted, if they are present, across all the sources, for example, a verified NHS number. If any deterministic identifiers match, the pair are assumed to match. Otherwise, Patient Index compares a list of demographics known as parameters between the two identities using intelligent algorithms. Each parameter comparison generates a matching score, and the scores are added up to make the link weight for the pair. If this exceeds a set threshold, the pair are assumed to match, so Patient Index links them. Finally, Patient Index applies a configurable set of expert system rules, which can result in a link being changed to a non-link or vice versa. For example, Patient Index might say that if the dates of birth and surnames agree and NHS numbers disagree, this could be a pair of twins, so unlink the identities. And Patient Index also decides whether it needs a human to check the result, which we will come to later. As a byproduct of the identity matching, Patient Index also identifies duplicates. If Patient Index matches two identities with different MRNs from the same source system, then presumably this is an error by the system administrators of that system, such as the hospital reception staff. They've created two accounts in their system for the same patient. Patient Index flags these as duplicates in the work list for a human to resolve in the source system, presumably by merging the two accounts. It may be that you absolutely trust that the PAS won't allow the same patient to be registered twice, in which case you can enable a domain conflict setting in Patient Index. Then, if Patient Index identifies a match between two identities in that source system, it won't link them. I mentioned that before comparing demographics, Patient Index first normalizes the demographics. First, it converts configured common placeholder values to blanks, so they are ignored for matching, such as the first name of baby. Then it applies configurable rules to ignore differences that shouldn't affect matching, such as spaces in NHS numbers, and to ignore invalid values. After normalization, Patient Index compares the parameters using intelligent matching algorithms. Each parameter is configured with an agreement weight and a disagreement weight. If the parameter matches, the agreement weight is added to the total score for the pair. If the parameter doesn't match, the disagreement weight is subtracted from the total score. How do you decide what agreement weight and disagreement weight to assign to a parameter? For the agreement weight, it's largely based on the number of different possible values. For example, lots of different people have the same gender. So just because two identities match on gender doesn't add much to our confidence that they are the same person. So we give gender a low agreement weight. Disagreement weight is a bit different. Our choice of disagreement weight is largely based on our confidence in the data, both in terms of quality and currency. For example, we may assign a higher disagreement weight to gender if we have confidence that the source systems are recording gender reliably, because gender generally remains the same, and two people of different genders are highly likely to be different people. And it's more likely that someone will enter a complex parameter such as phone number incorrectly, so perhaps a mismatch of phone number should not push us as strongly to say that these two identities don't match. Lastly, the matching algorithm may assign a score that is less than the full agreement weight. This could be because Patient Index has detected a partial or uncertain match. Or it can be because the value is more common than the average, so gives less certainty that the two identities are the same. For example, David is a more common name than Benedict, so a match of David as first name may score less than a match of Benedict. This slide shows how Patient Index uses many different algorithms depending on the real-world nature of the parameter. I'm not going to go through the algorithms. They are described in the online Patient Index documentation. So we've discussed how the matching works. Now I'm going to explain how we can configure the matching behavior. All of the basic configuration can be done through the management portal. Go to HealthShare and then Patient Index. You can see in the menu on the left that there are several areas of configuration and functionality. The top item, Definition Designer, is the main area for configuring the matching. If we click on it, that opens the Linkage Definition Designer page. Most of the configuration is stored as XML in a linkage definition class. In this example, we are using the default linkage definition class, local.linkage.definition, but we can create and use other linkage definition classes, which is why this page has new, open, and save buttons. There is also a button to reset the parameter weights to default values and a button to rebuild the linkage data. That causes Patient Index to delete all its match information for all patients and rebuild it from scratch. You need to do this if you make changes to the matching configuration that you want to apply retrospectively to existing identities. The linkage definition configuration is divided into four main areas. The Data Classes tab allows us to specify the table containing the original identity information. This is usually the hspi.data.patient class, and you wouldn't normally change this. Also, when the linkage definition class is compiled, the compilation automatically creates and compiles two other classes, the normalized table and the classified table. The normalized table contains the patient identity linkage parameters after normalization. It is this table that is used for matching. The classified table has a record for each identity pair that got through the link key indices. It contains the linkage calculated values for the pair and the decisions made, such as whether the pair is linked or not and why. This is the basis for the work list that we will see later. These two tables are cleared down and repopulated when we rebuild the linkage data. Here we see the general area of the linkage definition. We can select the locale, which affects things like date formats and the frequency of names, and we can enable or disable domain conflict, which controls the handling of duplicates. The synchronize MPI ID and linkage status is normally left checked. This means that linked identities will automatically have the same MPI ID, and unlinked identities will automatically have different MPI IDs, which is how Patient Index identifies sets of matching identities. Skip creation of strong non-link by threshold is also normally left checked. This means that if an identity pair scores less than the review threshold, a record is not created in the classified table. This greatly reduces the size of the classified table, and such identity pairs usually don't require human review. The record summary display expression the record summary display expression allows you to control what appears in the summary column in the work list for each pair. The data classes shows the classes used to store the original patient demographics and the search criteria used by external systems querying the Patient Index API. You can't change these. When a new or updated identity is received, it must be compared to all existing identities. Doing the full matching against potentially millions of existing identities would be very costly, so all the obvious non-matches are eliminated by the link key indices, and only the remaining records go through the full matching. There are two types of link key index, automatic and manual. The manual link key indices are used for identity matching during patient search. We'll come back to them. The automatic link key indices are used for matching when a new or updated identity is received. You can create any number of link key indices. Each link key index specifies a set of parameters to match, the code to get their values from the normalized table, and a minimum match count. In this link key index named main, the link key index contains given name, family name, the street line of the address, the postcode of the address, and the date of birth. The minimum number of matches is set to 3. This means that if any 3 of these 5 parameters match, then the identity pair goes for the full matching. Otherwise, Patient Index tries the next automatic link key index. If none of the link key indices meets the minimum matches, the identity pair is dropped. The matching doesn't go any further. The second automatic link key index in this linkage definition is simply the SSN. The SSN property is typically used to store the National Health Identifier, such as the NHS number in England and Wales, the Health and Care number in Northern Ireland, the CHI number in Scotland, or the IHI number in the Republic of Ireland. This link key index has a single parameter and a minimum match count of 1. So if the two identities have the same SSN, then the pair goes for full matching. Together, these two automatic link key indices are saying that an identity pair should only be considered for full matching if either 3 out of the given name, family name, street address, postcode, and date of birth match, or the SSNs match. Anything else is considered an obvious non-match. How do we decide which parameters to use in link key indices? First, we should choose parameters that we think have good data quality in all the source systems. The parameters are likely to be populated and they are likely to be correct. And second, the parameters should have a wide range of values so that only a small set of existing identities pass the link key indices test and go on for full matching. So date of birth is probably a good link key parameter, but gender isn't. A patient search is very much like a new or updated identity match. Essentially, the only difference is that the candidate identity is made up of a set of search criteria, either by a user or a system using the Patient Search API. Patient Search uses the automatic link key indices, and you can define additional manual link key indices just for search. The link key index name must start with search. Only if at least one automatic or search manual link key index scores its minimum matches between the search criteria and the identity does Patient Index go on to try the full matching. In this example of a manual search link key index, the user must enter at least 2 out of given name, family name, and date of birth, and then at least 2 of those must match an identity for it to go for full matching for the patient search. Patient Index then lists the identities that made it through the link key indices check in the search results, ordered by descending match score. Now let's look at the fuzzy logic matching parameters in the linkage definition. This is where the matching goes if the identity pair passes the link key indices test. The parameters are listed on the left, and if we select one in the list, we can see and edit the properties of the parameter on the right. Parameters that haven't been assigned an agreement weight and a disagreement weight are not used in the matching. We wouldn't match on facility, assigning authority, or MRN because if they match, then the incoming identity is assumed to be an update to the existing identity. In this example, the parameters used for matching are the patient names, the SSN or National Health Identifier, gender, date of birth, identifiers such as driver's license number, patient addresses, and patient phone numbers and email address. Parameters can be added and deleted. Here we are looking at the properties of the names parameter. At the top, we also see the thresholds. These are not part of the parameter properties, and we'll come to them in a minute. First of all, the parameter has a name. Here the name is names. Then the normalized property name is the name of the property to create in the normalized data table that holds the normalized value for the matching. The display expression is an object script expression that calculates the value to display for this parameter in the work list. Here it is the given name and surname taken from the original unnormalized data. The original object property of the linkage parameter gives us access to the original unnormalized data. Below that is where we set the linkage type used to compare the parameter values between the two identities. Here we are using the name linkage type, which is designed to compare patient names. Next to it, we can set parameters that control the behavior of the linkage type comparison. You can set each parameter value in turn by selecting the parameter name in the first list and then the value to assign to that parameter in the second list. Here we are saying that we want the comparison of patient names to be frequency adjusted. That means that common names such as John and Smith will score a lower proportion of the agreement or disagreement weight than less common names, because a match of a name such as John Smith gives us less certainty that the identities are for the same patient than a name such as Benedict Cumberbatch. The original property name specifies the name of the property in the original data table that will be used to generate the normalized value. If the original table has more than one property that stores the same data, you can specify them as a comma-separated list. The agreement weight and disagreement weight allow us to control how much this parameter contributes to the overall match score for the identity pair. The list of values to be treated as null is where we can specify a comma-separated list of common placeholder values that we know users are entering. And the normalization function and agreement function allow us to customize the normalization and matching behavior. The normalization function normalizes the original property value to get rid of any differences that should not affect matching, such as removing spaces from an NHS number. The normalized values are stored in the normalized table whenever a new or updated patient identity is received or the linkage data is rebuilt. If you leave the normalization function text box empty, the default normalization, if any, for the linkage type is used. You can override that default behavior with any object script in the text box. Your code has access to the normalized object, the property name, and the configuration settings on the linkage parameter. Your code must return the normalized value. This example calls the default behavior for the gender linkage type and then converts anything that is not M or F to unknown. Similarly, the agreement function text box allows you to customize the calculation of the link weight for the parameter comparison. Your code has access to the normalized objects of the two identities, the normalized property values for the linkage parameter, and the linkage parameter agreement and disagreement weights. This example says that if the two normalized values are the same, return the agreement weight. Otherwise, calculate a match code using the edit distance comparison for the values as dates. If the match code is 1, return half the agreement weight, otherwise return the disagreement weight. The thresholds that we can set in the Parameters tab control what Patient Index does with the total link weight calculated for the linkage parameters. The Adjust Thresholds button shows this histogram of link weights in the classified table to help in choosing the link weight thresholds. If the link weight of a pair is below the review threshold, the result is a strong non-link. Patient Index is confident that the two identities are not for the same patient, so it does not link the identities. If the skip creation of strong non-link by threshold setting is not set, Patient Index creates a record in the classified table for the identity pair and sets the link status to strong non-link. Otherwise, this histogram won't show any entries below the review threshold. If the link weight is between the review threshold and the auto-link threshold, Patient Index thinks the identities are not a match, but it wants a human to check. So it creates a record in the classified table, sets the link status to non-link for review in the classified record, and does not link the identities. If the link weight is between the auto-link threshold and the validate threshold, Patient Index thinks the identities are probably a match, but it wants a human to check, so it sets the link status to link to validate in the classified record and links the identities. If the link weight is above the validate threshold, Patient Index is confident the identities are a match. It sets the link status to strong link in the classified record and links the identities. In some circumstances, you may have a patient identifier, such as driver's license number or passport number, that you trust to be accurately recorded in some or all of the source systems. If so, you can set that identifier as a deterministic identifier. Then, if the identifier is present in both records when doing a match, the comparison of the identifiers overrides the weightings. If the identifiers match, patient index links the identities. And if the identifiers don't match, then patient index unlinks the identities. That can still be overridden by a human doing a manual link or unlink of the pair, or by expert system rules, which we will come to. To use an identifier as a deterministic identifier, it must first exist in the Unified Care Record Registry and must be set as an additional patient identifier, as you see here for 3 of the identifier types. The exact match setting doesn't matter in this context. Then you must edit the linkage definition class in Visual Studio Code or InterSystems Studio and add a class parameter named deterministic identifier types that is a comma-separated list of the identifier types to use as deterministic identifiers. Again, you would only use this if you are confident that all the source systems that have this identifier are fully trusted to have it correct. Otherwise, you can code an expert system rule to do the same job, but with more flexibility. When we come to look at the work list in part 2, we will see that one of the columns displayed for the classified records is an agreement pattern. This is a shorthand for the results of the weighting calculations for the linkage parameters in the linkage definition. It is a string with a single character for each weighted parameter in the order that the weighted parameters are listed in the linkage definition. X means a strong negative with a negative link weight, typically the parameter's disagreement weight. L is a weak negative, a positive link weight, but less than half the agreement weight in the parameter. H means a high match, more than half the parameter's agreement weight, and N is for neutral. The link weight for the parameter is 0, which typically means the parameter was blank in one or both of the identities. The weighting calculation can be followed by the execution of expert system rules, which can use real-world understanding to change the result of the weighting calculation. There are some rules out of the box, and you can override or add to the rules by writing code in the linkage definition class. I've listed the out-of-the-box rules here to give you an idea. For example, the first rule is saying that if the weightings for a pair resulted in a strong non-link, but the NHS numbers agree, the identities are perhaps the same person after all, perhaps with a changed surname and address. So change the status to non-linked to review for a human to check. Or the twins A rule says if the identities were linked by the weightings and the dates of birth and surnames are the same, but the NHS numbers are different, then perhaps these identities are for twins rather than the same person. So again, get a human to check. And the roommates B rule is saying that if the similarity was high enough to cause a link, and it was the address or phone number that scored highly, but the names are different, then perhaps these are 2 different people living together. If you want to create your own expert system rules, this requires some coding in object script in the linkage definition class. You override the onCreateClassifiedPair method, which is passed the classified record resulting from the weightings. Your code is only allowed to change the link status, secondary reason, and comment properties of the classified object. By changing the link status, you can, for example, change a pair that has been linked into a non-link for review. The secondary reason property allows you to specify briefly a reason why you made the change, typically a name for the rule. And the comment property allows you to give a more extensive description of why you made the change. Using the classified object, you can get the original and normalized objects for the identity pair, which are typically referred to as A and B. Then your rule can make use of any properties of the original and normalized objects to make its decision. If you want to include the standard rules and just add your own, then your method can start by calling the superclass implementation. If you make any changes to the linkage definition, you must recompile the linkage definition class and rebuild the linkage data so that your changes are applied retrospectively to the existing identities. Recompiling the linkage definition class does stop patient index for a few seconds. Rebuilding the linkage data can either be done in block mode with patient index linking stopped or in incremental mode with patient index running. That reduces downtime but takes longer. When you rebuild the linkage data, you choose what data is rebuilt, depending on what changes you have made to the linkage definition. For example, if you have simply changed the weighting thresholds, you can choose to recalculate the link statuses, but without recalculating the link weights. If you have changed the link key index definitions, you must rebuild the link index data and the classified data. And if you have changed the normalization behavior, you would choose the normalized option to rebuild the normalized data, the link index data, and the classified data. In all cases, any manual links and unlinks are retained, which keeps the decisions already made by human intervention. Be aware that rebuilding the linkage data can take a long time if you have a large number of existing identities. Referential matching is a new feature of Patient Index, so let's take a look. So far, we have only discussed identity matching carried out by Patient Index based on demographics it is receiving from connected source systems. We are relying on those systems to have a complete and accurate set of demographics for all the patients. Otherwise, our identity matching may not work well. But there are services available known as referential data services whose purpose is to collect a full, accurate demographic record for all the citizens in an area or country and provide an API that can be called to search for citizens by some criteria and returning a matching list with match scores. So it would be good if Patient Index could use such a service to provide demographics and assist in matching. That is what the new referential matching feature does. So how does it work? When Patient Index receives a new or updated identity from a source system, it makes an API request to the referential data service with those demographics. The referential data service returns a list of matching identities with a match score for each identity. Patient Index takes the result with the highest match score. Provided that the score exceeds a configured threshold, Patient Index takes the referential data service ID from that result and sets it on the source system identity as an RDS identifier. Then, when comparing identities from source systems, Patient Index treats the RDS identifier as a special trusted deterministic identifier. If both identities in a pair have RDS identifiers and they are the same, Patient Index links the identities, but if they are different, Patient Index unlinks the identities. This link reason has a higher priority than any other link reason except a human manual intervention. To avoid delaying the inbound pipeline, the requests to the referential data service are carried out in the background, and the classified records are updated when a response is received. That raises the question of whether we can use the NHS Spine Personal Demographics Service FHIR API as a referential data service with Patient Index. After all, PDS holds demographics for all patients registered with a GP in England. One of the PDS FHIR API requests is a search request. It takes a set of demographics in the request, such as a patient's name, date of birth, gender, and home address, and matches them against all the patient identities held in PDS. The API then returns a list of matching identities with NHS numbers, each with a match score, which is exactly what the Patient Index referential matching feature needs from a referential data service. So although we haven't done it with any customer yet, it should work. So far, I've just talked about how Patient Index works with HealthShare Unified Care Record, But Patient Index does have a full API that can be used by external applications. The API allows an external application to add or update an identity, the same as if it was sent by a source system through Unified Care Record, merge two identities from the same source used when resolving duplicates in the source, delete an identity, search for matching identities given a set of search criteria, get the patient index unique identifier for a patient, the MPI ID, given the MRN of an identity, and get the composite record for a patient given the MPI ID. Patient Index also has full API support for standard IHE profiles, including PICS updates and PDQ searches, although IHE profiles are not so widely used in the UK. So I hope you enjoyed Patient Index Part 1. The next InterSystems Tech Talk will be Patient Index Part 2, scheduled at 10:30 on the 24th of October. In Part 2, we will be covering configuring and using the work list, the Patient Index composite record, and Patient Index data quality reporting. We'll send you an email with a link to the recording of this session and a link to register for Part 2. If you have any further questions on this Tech Talk, you can contact me on my email address here.
Oh, Paul, there is a question.
Deepak
has put a question in the chat.
What about unmerged scenario being supported by the API? So Patient Index does not support unmerge, so the API doesn't support unmerge either.
Okay, thank you.
Any other questions? Okay. Thank you for watching. See you at Part 2.